Okay, so once again, I think made an outline what we do, but it's I will be talking about TCP versus UDP used for file transfers. Why we do that? Because we want to speed up and simplify the ingest and distribution of files, of large media files. Another big thing with file transfers that you need to have the necessary tools to make this, fast, reliable, and secure at the same time. And that's another goal. And there's a big talk in the industry about moving a lot of services to the cloud. That's a big part of the equation is how do we actually get the media into the cloud, and this is another topic that we work with a lot. So let's get back to the basics. Does everybody know what's TCP? TCP is the underlying protocol for anything that is being transferred on the internet today. Internet would not be able to function without TCP. So it provides the control and reliability and security for all the internet protocols out there, such as FTP, HTTP, SFTP, or any other protocol, the SMB, for example, for Windows file sharing. So all these protocols use TCP, and TCP has been around for a really long time. It's been around since probably early 70s. It's been optimized for reliability and fairly small amount of data. Now, if you want to start moving really, really large files, what's going to happen is that you're going to start seeing, you're not going to be able to maximize the bandwidth because of the latency and packet loss that you have on your line. So here, I'll give you an example. When a TCP-based protocol is transferring a file, it's a very sequential process. So I will, for example, send you a file here. So I'm going to send a little bit of data to you, and you're going to tell me when you get it. I'm sending you data. Did you get it? Yes? Okay. I'm sending you more data. Did you get it? Yes? Okay. I'm going to send you more data. So what we're doing, every time I send you a little bit of chunk of data, I'm waiting. I am not sending any data. Now, this is pretty simple here because you're sitting across the room from me. Now, what about if you were on the other end of the hall? Now, I got to wait for this acknowledgement to come to me because it's such a far distance. Once again, I'm slowing down my transfer rate just because you're getting further and further apart. And that's what's called latency on the network. The higher the latency on the network, the slower will be your transfer. And the way you can really find what's the latency between those 2 points, you can open up a command line in either Windows or your Mac OS and just type in a ping and see what speed, what RTT. It's going to show you exactly what's the RTT, and that RTT is the round trip time, how long for a packet takes to go and come back. So what we decided to do is to actually take this data and send it over another protocol that has been around for a really long time, which is called UDP. So UDP is very lightweight. It allows you to send data as fast as you want. There's no controls of how fast you can, of how fast or how slow you're transferring files. And there's also no correction. So if there's a packet that gets dropped over UDP, you lose this data. So if you take a regular UDP, just regular UDP protocol, and then start transferring files, what will happen is two things. You will receive corrupt files, and you will also flood your network because your network will be going, you'll be going so fast on your link that the entire transfer the entire line will shut down. So what we did, we're using that UDP for moving data, but we actually, within our protocol, we control how fast the data is going to flow, and we track of any packet loss or any dropped packets while we transfer the files. So this allows us to move the data, instead of one packet at a time waiting for an acknowledgement, I'm going to now do this. I'm sending you data. Let me know if you're missing a packet. I'm sending you. I'm not waiting for a response anymore. I'm just continuously sending the data, which allows you to now, take your bandwidth and fully optimize it. So that's, in a nutshell, what acceleration technology means. It's just, we're not taking your bandwidth and making your line faster. We're just providing you as much bandwidth as possible in your current line. So the most common issue with this is that, a lot of people will say, okay, I have a 10 meg line. Files are not going fast enough. Well, let's get the 20 megabit line. But that's not the solution. The solution is really to optimize the 10 megabit before you move on to the next 20 megabit. Oh, there we go. I'm getting sound effects again. So what we do with FileCatalyst, there's some of the things as I mentioned here. We have the retransmission. If we lost packets, we'll do that, and we'll also make sure your line never crashes. So we will see how much that line can take of data can go through it, and if it's too much, we will slow down just enough for all the data to go through, but without your entire network crashing while you're sending the data. The other thing what we can also do, because this is now all going over UDP packets, we can spread the whole processing onto multiple cores. So you're sending data using multiple threads, and you're optimizing your entire system. So you don't need basically means you don't need a very powerful system to send data really fast with FileCatalyst. And once again, the big thing with congestion control, this is what I mentioned about flooding your network. That's a big thing when you're trying to do any kind of UDP-based file transfer. You want to make sure that when you're sending the file, that you still can browse your internet, that your VoIP lines work, that you still receive your emails. And that's one of the things that the congestion control allows. And the key here is to make sure that we don't take so much line that we leave some space for other applications to work with. And that's something what we do as well with our protocol. So what kind of speed gains we can do? This is just an illustration here this is within North America to transfer. Okay, this is North America. So this RTT here that you see, that's 40 milliseconds. This is what's an average within North America to send a file. This is how long it takes for that one packet to be sent and then received back. If you take this example here, this is a 40 megabit line, you end up with FTP going at about 6 megabits, and FileCatalyst using almost the full bandwidth. So once again, the recovery of bandwidth here is almost 38 megabits. Similar case with North America to Europe, and North America to Asia. It gets even worse because now you have 320 milliseconds latency, so you're recovering quite a bit of data. You're recovering 43 megabits. So what does this translate to in time? We'll just take this bandwidth. FTP, here's an example here with the RTT. LA to Hong Kong, RTT of 250 milliseconds. FTP takes 44 hours to transfer that file. You take 20 minutes. So it's not magic. It's not like we're compressing this stuff. It's just correct use of bandwidth to transfer the files and maximizing what you already have. Here are some of the clients we're working with. We have a number of resellers as well here in India that we're working with. If you're interested in those relationships, come and see us. And let me just go over a little bit how we package all of this. So what you want to do here is we provide you an off-the-shelf solution. So it's not custom built. Of course, you can do some customizations later on, but it basically works out of the box. And this provides you, with a full package of the tools for transferring files. The big thing here is that, you know, because the same build, the same package goes from, you know, one company to another. There's a lot of testing being done. It's a very proven way of packaging this type of software. The features, we build a feature for one customer, and the next build, everybody else will get that build for the customer. So it's an important way to look at it versus a custom built solutions. And high performance, you could hire, you could hire somebody that schemes that, you know, did some file transfers on the side, but has never really built a true accelerated file transfer system. And this is somewhere where we can come, getting a COTS solution that is built by specialists will make a lot of changes. And the ownership and control of data. Once again, we can go to the cloud model, but very often you want to move this data point to point as fast as possible. And that's something you should be looking at as well, that you can do that. Just to introduce very quickly, so how do we do these file transfers? There's, you know, there could be, some people think of file transfer, think of FTP and just moving files with FileZilla. Somebody else will think, well, I have a large email attachments, and I want to send an email, send my file via email. Somebody else might be thinking, I want to just do a command line and just do something, script something command line. All of these are really file transfer. It's just different tools, and that's how we package our software as well. We package it by, you know, either a point-to-point solution or a web-based solution, or if you want something on the cloud and move the data to the cloud, we're also integrated with most of the large cloud vendors out there, so you can deploy it there. So just to give you a quick overview here, FileCatalyst Direct is our point-to-point. So this is where you have a watch folder. That watch folder that maybe not everybody, you know, it automates all the transfer. You just drop a file in the folder, and the file will go to a predefined site or location. We have our Express, which is more like a FileZilla type of workflow where you have two panes. On the left-hand side, you see your local files. On the right-hand side, you see your remote files, and you just drag and drop between them to move the files. If you're looking for web-based stuff, because you want to do some web-based ingest, we also have Java applets. Command line tools as well are available for developing and integrating this stuff, and mobile applications. So there's just some examples here, illustrations of how these applications look. So there's the watch folder here. Here's the watch folder. You create your sites, your scheduler, and you send the files using the watch folder. You have something like a FileZilla, more of an interface, or an SDK here. Java applets, this is something that you can take on your website and post it as send basically someone a link. Here's a link, send me files. It's another type of, depending on the workflow you want to do, this is something that you might want to do. The nice thing with the Java applets is that you don't need any client-side application then. All you need from the user is just a web browser and an internet connection, and the user will be able to connect and upload or download files. So FileCatalyst workflow is more on the web-based side. Now here we're getting into a web-based portal for transferring files. There's two types of really transfers. There's an ingest and a distribution side of things. So ingest, think of it, I want somebody to send me a file. And if you think of distribution, I have this file, I have a user's email address, and I want to send it to that user. It's two different type of workflows. In fact, they're similar, but one is more for you receiving data, and you know where the data is going to go to a predetermined location, versus where you want to distribute a file to 5 people with an email address. And that's what workflow really controls. And you can control all your locations and paths where the stuff is stored on storage. It can connect easily. You can have an ingest type of a workflow where a user uploads a file and gets ingested into a MAM automatically via the interfaces that we provide in the workflow. Webmail is just another type of an application that it's really just for the large email attachments. So some people say, I don't care about receiving files, I just want to be able to send large files to my customers. It's a bit of a simpler application. It allows you to distribute files via email to anyone in the world just by typing their email address. API, I'm not going to go through the list here, but it's once again an integration and tools, and that's our goal here, is to provide the tools to be able to transfer files as fast as possible with the right tool. So whether it's a command line or an API, we provide a number of choices for transferring this, for integrating into your existing workflow. So another aspect of file transfer is you want to know what's going on right now on your transfer. So you may have, 10 different people uploading files, and you want to be able to visualize it all on the console. So you can connect to something like a product like Central, and it will actually show you which nodes are sending a file. You can speed them up, slow them down, cancel a transfer. You can also go inspect the logs and see what has been sent. So if you're looking for file XYZ, you can search for it and find it quickly across your entire system. You don't have to go into every single log and parse logs to find it. So that's on the management side. The cloud solutions, so this is, there's two things people want to do. One is that they want to actually, you can install our software on any cloud, on a cloud vendor, and just basically using it as a platform for, uploading files. The other option is that you want to actually send the data to your cloud vendor. So you produce the large media files, and then those media files are being sent to the cloud for distribution or for encoding or whatever else you need on the cloud. So we can do both. We can help you to get the files to the cloud, or leverage the cloud just as a platform for actually hosting all this, all our software. We also can provide you with our own hosted solution. If you don't have a hardware or don't have a private cloud, we can also provide you with that. So, in summary, TCP has been around for a long time. It's been used a lot. It is good for smaller data, slower links, but as soon as you go into faster links of 5 megabits and up, and files of 8 gig or more, you should be looking at some kind of an accelerated system to move these files. You keep in mind that our solutions are fairly modular, so you can start with a very basic workflow, for example, like FileZilla type of workflow, or move to something more web-based right away. So you can start with a small piece and expand on it as your sort of knowledge and expertise and your workflow, improves with time. We are going to be here in the booth F616. You can visit us there if you have any questions, or you can just visit us online, and a lot of this information material is covered on our website. That's it. Any questions? Yes? Could we get a mic?
I have two questions. First is, how efficient is it on a lease line scenario?
I'm sorry, on what?
How efficient is the software on a lease line scenario? See, it's efficient on an internet base. If I have a lease line, point-to-point connectivity, how efficient does it work on that kind of scenario? That is question one. And how would you differentiate from Aspera?
Okay, for the leased line, are you talking about a leased private line? Once again, it's depending where the two endpoints are. So if your leased line is, let's say, within the city, then the acceleration is not going to be as good because you're not going to have as much latency. But as soon as the leased line the two endpoints are, let's say, one in Mumbai and one, let's say, in Europe, then you're going to see an improvement just as much as you would do with the internet. And as to your second question, against how we compare it to against Aspera, few things. First of all, we have, because everything is fairly modular with us, we have a very low, entry cost of entry to use our solution. So you can just purchase a fairly small piece and get started using it and then grow with it as you need it. Second thing what we do is that when we provide our solution to you, the client applications that I talked to FileZilla, the watch folder, the command line, all of that is for you. You can freely distribute to all your customers. So now you're providing them with a file transfer tool without you incurring any additional charges. So our licensing is not based for every single installed piece of software, but rather on the server connections. And on the technical side, where we also differentiate is that if you have faster lines, up to gigabit, pretty much every vendor can handle 1 gigabit transfers in this market space. But if you're going to 2 megabits, 2 gigabits or higher, there are very few that can do it, and I think we're the only ones. The last thing is the ability to do deltas. So if you transfer large files, you send a 10 gig video file, and then you realize there's a typo at the end of the file, we don't have to retransmit this entire file. We'll just retransmit the delta. What changed? The changes. So you're not retransmitting 10 gigs again. You're retransmitting maybe just a little portion, a few frames where the typo was. So those are sort of the key differentiators.
There was one more thing you mentioned in your presentation was like we can manage the transfers in the sense like if there are 2-3 transfers going on, we can increase the speed or bandwidth to one of the transfer and we can prioritize one of the transfer with the other. So it would be within the same bandwidth available to that particular. So is that feature what is I think the differentiation?
So yes, you can prioritize your transfers on the fly. You can just select the one you want and you can override the priority or set the exact bandwidth. So for example, if you have, if you only have on your server location, let's say you have only a 45 megabit connection and you have 3 clients trying to all send you at 45 megabits, well, you cannot do that. You only have 45 for all 3. So you can decide which one will maybe get more bandwidth and the other guys will go a bit slower. So that's on the prioritization. And another thing what you can do, you can also, you have something called, what we call deliver ASAP. So you click on this connection and say, I want this to receive as quickly as possible. And our server will actually decide, okay, these connections are slower. Let me adjust my bandwidth accordingly. So you don't have to do all the calculations in your head. You can just say, I want this file as quickly as possible. Anything else?
Well,
actually, I just wanted to add one more thing about resuming interrupted transfers. So that's usually a question that comes up very often in our forums and when I speak. When you interrupt a transfer, I'll just give you an example with FTP. What happens? Let's say I transfer a file, connection breaks. With FTP will remember the pointer or will remember the last part where it stopped and will blindly resume that transfer. So if there's a few bytes of data that didn't make it, FTP doesn't know that. So it's basically blindly resuming from that point on. With a proper automatic resuming, what you want to do, you want to have the pointer, but you also want to do an MD5 checksum of the file up to that point of interruption. And if that matches, then you resume the file properly. If it doesn't, you start from scratch because there was some kind of corruption on the line or something happened. But this guarantees that your interrupted transfers will always arrive, intact because it will automatically resume after MD5 matches. Okay. Well, thank you.
Well, we have lunch and we have to come back at 1:30. So grab a quick bite.